In wires, the charged things that are flowing, the electrons, are negative. But in liquids, they're negative and positive ions moving in opposite directions. It turns out that it's easier if we pretend that electric currents always consist of positive charges moving in the sense positive to negative. And this is called conventional current. When negative charges, like electrons or negative ions, are flowing, we imagine replacing them with positive charges flowing in the opposite direction. So all our simulations from now on will show conventional current. We'll show positive charges moving in the sense positive to negative. And this is how all of science treats electric current, so you end up not having to worry about it. You might well ask why we don't just change to the direction that electrons are really flowing in. And the answer is that it doesn't matter what convention you use, as long as everyone uses the same one. All the complex mathematics that ties together electricity and magnetism developed over the course of 200 years or so, and it assumed that it was positives that were flowing. Changing it would mean rewriting millions of pieces of science for no obvious benefit. It's like which side of the road we drive on. In the UK, we drive on the left, but in most of the rest of the world, people drive on the right. We could change to driving on the right too, but that would be really complicated, expensive, and confusing, so we don't. At least with conventional current, everyone in the world drives on the same side. In electric circuits, the charges are already there, and they all start moving everywhere at the same time. So it doesn't really matter which way we think they're moving.